This is primarily where emotional processing occurs in the brain. It includes structures such as the amygdala, the hippocampus, the mammillary bodies, the fornix, and a whole bunch of names nobody's going to honestly remember at the end of this talk. So let's get to what matters. The amygdala. So the amygdala translates to the almond. This highlights that in addition to the renowned creativity that scientists are known for, they tend to skip lunch. So the amygdala is known for a couple things. It's known for its role in memory, decision making, and emotional reactions. And while it is known primarily for its role in fear processing, it also plays a role in appetitive and addictive behaviors, which we'll talk about later. So, the amygdala. It receives input from the auditory cortex, the somatosensory cortex, and the visual cortex. These inputs, in turn, are relayed to the hypothalamus, and then further relayed through the hypothalamic pituitary axis to target tissues. Ooh, more fancy words. So essentially, the amygdala takes sensory information. It relays it to the hypothalamus, which releases hormones into the circulatory system, and the circulatory system reaches target tissues. Here we have the adrenal glands. Add renal on top of the kidneys, again, more scientific creativity. This gland releases two hormones of interest tonight, adrenaline and cortisol. Now, adrenaline and cortisol are known for their role in the flight or fight response. It is for this reason that we posit that the amygdala pairs the perception of threat via sensory stimuli directly with the flight or fight response. And so as we can see, adrenaline and cortisol, we have an increase in heart rate, an increase in pupil dilation, frankly sweating. With that being said, because everything is more elusive with simple arrow diagrams, I give you the exciting arrow diagram. So we start with sensory input, something that's scary, some sound that you hear in the night when you're trying to sleep and you have a final the next day, something that you visualize, such as your grades after the tests have come back. Then we have activation of the amygdala. The amygdala, in turn, activates the hypothalamus. The hypothalamus leads to the production of adrenaline, amongst other hormones, which in turn leads to the flight or fight response. Everyone with me so far? Beautiful, beautiful. All right, let's move on. So in addition to the amygdala and the hypothalamus, more recent research suggests that there are other brain areas and mechanisms that are involved in not only the experience, but the induction of fear. Among these regions, besides the ones that we have exhaustively talked about, include the insula. And so the insula is right here in this nice beigeish colors and bold text, trying to make it as easy as possible for us to detect. But in terms of addiction, which is what we're here tonight to learn about, we see, regardless of whether we're talking about substance addiction or adrenaline addiction, very distinct neural patterns. So, we start with an increase in limbic system dopamine, dopamine being a neurotransmitter associated with reward, in a region known as the nucleus accumbens, illustrated here. This is, of course, happening during the task. There's this high of, I'm jumping off a building, I'm parachuting, I'm skydiving, whatever. That is the region that is active during the activity itself. Next, following the activity, when you're just obsessing about it, thinking about, oh man, I can't wait for the next time I jump off a cliff, because some people think this, you have activity in the prefrontal cortex, so higher cognitive area, you're just thinking about it. And finally, once the withdrawal has happened, you need that high, you need to go do things that are more and more risky. You have activation in regions such as the insula and the amygdala. So this is also seen in, frankly, adrenaline junkies. So there is a long-standing correlation between high sensation seekers, i.e. adrenaline junkies, and drug use. Those who are high sensation seekers are more likely to try drugs, to become addicted to those drugs, and to try more types of drugs than those who are low sensation seekers. This is posited to be due to the fact that upon presentation of novel stimuli, be it drugs or skydiving, you have a rush in limbic system dopamine to those reward areas. So for this reason, we posit a couple things about high sensation seekers and their neurobiology. They could have a lower set point for fear extinction, meaning that they are